Hello Bio 30 class, this is Mr. MacKay again. Today we're going to start looking at the sex-linked genetic problems. These work a little bit differently than the autosomal genetic problems. Remember, we have 23 pairs of chromosomes, 22 pairs are called autosomes, and then our 23rd pair are called our sex-linked chromosomes or our X chromosomes. If you're a male, you have an X and a Y sex chromosome. If you're a female, you have two X chromosomes. So, show the question number one here. Show the result of a normal man marrying a colorblind lady. One thing you do have to remember is that colorblindness and hemophilia, for that matter, are both recessive X-linked diseases, which means it's a gene that's carried on the X chromosome and it's a recessive gene. So you have to have the recessive gene, at least one copy if you're a male, to have the disease. So let's make one legend. I'll just do one legend on this for the next four questions. It'll be the same for all of them. So on the X chromosome, we have to have a letter. I'll just pick B for color blindness. C's are no good. So on the X chromosome, if you have a capital B, that means you have normal vision. You are not colorblind. On the X chromosome, if you have a lowercase b, that's the gene for color blindness. Okay, that's the only legend we need for this question, and same with questions 2, 3 to 4. I'll just keep the same legend, then I won't rewrite it each time. So we have a normal man. So males are XY. If he's normal, meaning no color blindness, he has a capital B on his X. He's marrying a colorblind lady. Females are XX. If she's colorblind, because it's recessive, she must have a lowercase b on both of her X's. I've already not left myself very much room here. So let me make another page with that cross. And now we have to do the gamete. So it's XBY times X little b, X little b. So the male can segregate his two chromosomes in this way. He could have an XB in his sperm, or he could have a Y in his sperm. The female can have an X little b in her eggs, or an X little b in her eggs. That's her only option for this female. Let's do the Punnett square. And X big B, X little b. Just like in normal Punnett squares, you always put the capital letter in front of the lowercase letter. That's just convention. It doesn't change anything. X big B, X little b, X little b, Y, X little b, Y. X always gets written in front of the Y too, for that matter. Now, when you write out your phenotypic ratios, the way I'd recommend doing it a little bit differently, separate them out by sex. So, phenotypic ratio for the females. If you are a female, both females are the same, so you're 2 out of 2 carrier. Now, for sex-linked traits, you have to designate if the female is carrying the disease or the condition, but doesn't actually have the condition. So a carrier means you don't have the disease. In this case, you're not colorblind, but you do have the gene for colorblindness, because then you could potentially pass that on to your children. Females are carriers, or they're normal, meaning they don't have it, or they have the disease. They kind of have three choices there. In this example, both females, 2 out of 2, are carriers. For the males, we have 2 out of 2 that are both colorblind. There's your first one. Question number 2. What would happen if a colorblind man married a carrier lady? So I won't redo the legend that you saw in the first card. It's the exact same legend though. So we have a colorblind man, X little b, Y, married a carrier lady. So she's X big B, X little b. Set up your Punnett square, X little b or Y, X big B, X little b. X big B, X little b, X little b, X little b, X big B, Y, X little b, Y. And then phenotypic ratio, start with, doesn't matter which sex you start with, I'll start with females. Here we have 1 out of the 2 females are carriers, and 1 out of 2 is colorblind. For males, 1 out of 2 is normal vision, and 1 out of 2 is colorblind. Question number 3. Cross between a colorblind man and a colorblind lady. So everybody's colorblind here. Colorblind man, colorblind lady. Hopefully you can start sort of predicting what you're going to see already here. Everybody's going to be colorblind because both parents were colorblind. Hard to avoid it. So phenotypic ratio, female, 2 out of 2 colorblind. I'll just try to speed up here. And male, 2 out of 2 colorblind. That one's pretty straightforward. Last one. What if a normal man married a lady? So a normal man means he's not colorblind. Married a lady who is a carrier. So she's got one dominant allele in her X and one recessive allele. Punnett square. Quickly fertilize. So there's a lady normal. There's a lady carrier. There's a male normal. And there's a male who is colorblind. So phenotypic ratio for females. We've got 1 out of 2 normal, not colorblind. 1 out of 2 carrier. For male, we've got 1 out of 2 normal. And 1 out of 2 who is colorblind. And that's it for the introduction to sex-linked traits. Again, colorblindness and hemophilia, you just have to remember they're both recessive X-linked diseases. Any other disease, the question would have to give you some kind of a clue that it's an X-linked disease or carried on the X chromosome or something like that. They'd have to give you that information in the question. All right, that's it. Talk to you later.